At the previous lesson, we learned that this program contains one view model named game view model that maintains state of the GUI. And this view model is single and it is global and is shared between pages. This program has 2 pages. So you select something, this data should be preserved by the time when you go to second page. So this view model is accessed by both pages, so it is global. Also, at the previous lesson, we learned that you can have as many view models as you like. You can have them per page if it is necessary. It really depends on the selection of the task what you want to solve. So in this particular program, it is only one view model. And in the today example, we will also have one view model. So when I was explaining this yesterday at the previous lesson, we learned that state in this program is stored in 2 places. As mutable state flow of game state, and game UI state contains user choice, computer choice, and game result. In this version of the code, it's main. It doesn't have page name because page name is in simplest version. A page state is maintained by navigation system, and so we don't need to save it as a state if we use navigation system. So in this version, we don't have state which page to show. This is necessary only if you don't use navigation system. This state is stored in state flow, and we updated brute force by calling update. Also, this program has GUI state shows this dialog or doesn't show this dialog. It's also state. And it was a choice to separate it in different variable. State variable, show help, which is Boolean true or false. And this is mutable state of. So it is different type. A state flow is not designed directly to be used by GUI, so it has to be converted to mutable state. It has to be converted to state variable inside of the GUI if you want to use state flow to trigger GUI for update. So this is how it was done here. You see, when we receive it, this is state flow. We convert it into state, so result is game UI state. So this will be container that contains state, and at the previous lesson we learned that by is conversion, right? Not conversion, delegation. So we have a variable that delegates setters and getters to this container. And the container will trigger GUI updates. So when we assign something to this variable, container will handle it, and vice versa. In this case, we cannot assign to this variable. Why? Because it is state. It's not mutable state here. So it is collector state. The type is state, not mutable state. Next. What is delegated is getter, in this case. And why it is getter, it is explicitly val. You cannot assign anything to val anyway, right? So it is explicitly getter delegated. I've also said that it's a choice to store a state related to dialog is a variable inside of view model. You don't have to. If you have a state just something very GUI specific, not related to data, not related to calculation. Sometimes it makes sense to put it directly the state in a GUI. So it's a choice that we can do that, but it's not necessarily a hard prescription. So for this reason, in today's example will contain exactly the same dialog that shows up exactly the same way, but as a demo, I'm storing this in a GUI. So in the today example, state of show not show dialog, not to show dialog, is stored in the GUI into the example just to as a demo. That why not? Also, at the previous lesson, I mentioned that given view model does have a dependency. It depends on game service, and game service provides two functionalities: random choice and decide who is the winner. So it contains two methods. This is indeed dependency of view model. And it is hardwired dependency. It's not injected. It is just we call constructor and assign it. What is the issue with it? If it is dependency is assigned directly, in this case, assigned inside of a constructor, right? Because these assignments are body of default constructor. So when dependency is assigned directly inside of the body of the constructor, not coming as a parameter, I will have a huge issue, not huge, but some issue, that view model cannot be tested independently from this one. You have to test it together. And if there is some randomization in it, your test will not be reproducible because it's random choice inside. Previously, we could handle this randomization issue inside of game state. Where did I put it? Yeah, game state. If I move random number generator into as a parameter of constructor, in my tests, automatic test, unit tests, I can assign such objects that will make reproducible results. So it's a trick to make tests reproducible. So one of the choices is to provide seed to random number generator. If you provide seed some number, it will be reproducible sequence. So it will be kind of random, but it will be always the same sequence each time when you run program. So it's one of the choices to make it not completely random. It is done for testing purpose.
No.
There is one more choice, quite common. When you provide dependency, in this case, you do not configure object itself, like here you sit, but you imitate the object with another object. One way to deal with it is to use interface and just implement interface instead of it. Just another implementation. But it's not always best choice because you add extra layer if you use interface. Plus, if you use the interface, you would have to implement other features in the interface. So it's not optimal way. One more choice, and it was quite good and common, is to use Makita library. It's a mocking library. How it works. When you use this library, you can imitate functionality of a given class with another class created by the library. What is the imitation? You provide, for this function call, get this result. So you define outputs of function calls. So this way you can imitate behavior of any object. It is called Makita library. We will learn how to use it soon. It is super useful. But anyway, this object needs to be replaced, right? With if you mock it, you replace it with mock. Or, if you create random number generator with set, you replace it with set. It is fine here, but what would you do inside of game view model? You don't have access to this object. You cannot replace it. You cannot replace random number generator here, right? Yeah. Another choice, okay, I don't have it here, so why don't we push it as a parameter of game view model? The same way as we did for game service, we provided random number generator. Why don't we use game service as a parameter of game view model constructor? Yeah, why not? Issue is that our view models are created automatically by the system when they are necessary, right? When it doesn't exist, it will create one. If it does exist, it will find one. How on earth the system will know how to create this object? And where to get one? So it's an immediate issue. If we use this object as a parameter, it is definitely dependency, but when the system initializes, Android system initializes this view model, it will need to know how to create this game service. And remember that this game service may potentially depend on something. Right? So it's not that simple, right? So the way how it is done brute force is to give, to provide it as a parameter, still provide it as a parameter. And when we call it in our screen right here, when we call view model, we call this function with parameter. It takes parameter. This function can take parameter. But parameter, it is not the object that is passed to view model. No. Parameter is a factory object. What is a factory object? Factory object is the object designed to create other objects. So how this factory will be used? If this view model doesn't exist, it will call method of this factory to create one. And inside of the factory, you can pass parameters to constructor because this factory is your own class. You can pass parameters there. And if this object already existing, this view model function will ignore factory. So into the example, we will have factories there. In this, we don't. Okay? In the second example, today we will have factory. Because our view model will have dependency, that dependency is fancy, it is referring to database, so it is nicely done this way. So we will have factory then. So this would be dependency of a view model, and as the way to create, the way to provide dependency to constructor could be kind of manual. When you use factory, it's a kind of manual. Google created extra convenience functions to create this factory. Previously, it was just you call constructor of factory yourself, create class, call it factory. And now factory can be somewhat generated, so it's easier. Previously, we had to create view model factories. Now we use functions that is creating. So that would be a dependency kind of manual, because we still create a factory and provide it. Google made it more convenient about 2 years ago. So it wasn't, it's not new, and it's not old, about 2 years ago. And they started to call it manual And previously it was also manual, so it is the same essentially with extra convenience. But it is not what Google recommends for larger projects, because for larger projects, its manual dependency injection can become a lot of chores. Also, when we do manual, is the easy way to do it only when it's global. We cannot limit scope of the objects. So for larger projects, Google recommends using Hill dependency injection system. We will learn it next week. Because it's also a learning course, so it's postponed until next week. Hill dependency injection system. Today it is manual dependency injection system with coming example. I will also convert this one to show how it is with Hill, because it is simple. Or maybe, no, not this one, second example. I will convert with Hill. I will leave it as it is. So, let's quickly walk through the GUI to kind of explain a basic idea what is going on. This is app root screen, and when we call it without view models, what it is just default parameter, right? So if we don't provide view model as a parameter, it will call view model function, and it will keep the one here. This function app root screen is called from main activity, and it is here. See rock paper scissors theme, and it is here. Okay. So it call it without view model parameter, so it will use default one by function call of view model. So in app root screen, I call it root screen because it's root everything, right? Because we have function inside the function can be imagined it as a tree, so it's a root of that tree. It is my own name convention, root screen. Google call it app. Issue is that they call it, for example, if it is a paper or scissors, they will call it app paper or scissors or something. Issue is that we will have to create also class called application something. In this case, application paper or scissors. Sometimes we need to create class called application because it inherits from application class. Issue is that in your project you will have some class like paper or scissors app and paper or scissors application. Sounds the same, but for totally different purposes. In my opinion, it's a little ugly idea. So for the one that is actually screen, I call it root screen. I don't call it application, app. But in Google examples, they call it name, app. And application class instead of app, they call it application. So whatever. So what do we have here? We create navigation controller, and it is created with keyword remember because it needs to remember pages when we rotate the screen. So data is not lost. Our navigation host, our compose function, it is the window where pages are inserted. When we call this function, we provide navigation controller and start destination. It is address of the first page to show. Every page has an address, and this address is a string. In easiest case scenario, like simplest case scenario, these strings do not contain the data. But they can potentially contain data. And this is just a simple example where we don't need to insert data. In the example for next week, we will have a data in the address. So it is incremental increasing of complexity. Today's example will not have multiple pages. It is just one page for simplicity. So, how it works. Every destination is marked with composable and address, and in last parameter of the composable function is lambda function for the screen, to show what the screen will be when we navigate to this address. So I have a play screen and I have a result screen. For example, when in play screen I click on play button, it will call this function. So it is a lambda function passed as a parameter to, this is lambda function passed as a parameter to play screen. And this lambda function is attached to play button. This button. Okay. So what happens? First, I call play in view model, so it will update the data. It will pick user choice, put it there, calculate computer choice, and decide who is the winner. But previously, my view model was updating also state, and the system was reacting on the state, which is go to next page, right? Now it is updating state that does not contain page information. So I need to notify navigation system, go to next page. So for this reason, previously I had just this line, now I have this line, navigate to result page. So I'm calling navigate function of navigation controller to go to result page. So this is a trick. Yes. On help button, since my state show, do not show dialog is stored in view model, in order to update the state, I'm calling function of view model. This is lambda function, but this is just regular function inside of the view model. So type is mismatched. So I'm using double dot, this is conversion, function to lambda function. Because on this side it expects lambda function, on this side is just regular function. So double dot, it will become, it will match the type to lambda function. Also in result screen, I also have on help because this button also in the result screen. And on the result screen, I have on replay, this button. And now I could go back to navigate. But I decided to pop stack. What is the difference? Pop says when we navigate, it will add states to navigation stack. For what sake? For sake of back button. Android system has also iOS has back button, which is not just this button. It is kind of hardware button. Let's find it. This button, right? On device, it is at the bottom, right? So this button, even if it doesn't, this is not present, this button will pop stack. So when you navigate to one address, navigate again, it will maintain history. So it will save current location on the stack. So this way, pop back will go through all your choices unless you pop the stack. Okay?
Yeah.
So for example, I played paper, then I go back. I played scissors, and then I go back. Then again scissors and go back. Right? This will go through all this history if I click. Okay? This would be if I navigate to address without popping. Right? When I navigate to address, it will add state to the stack. If I pop, it will just go to previous state. So effectively, I'm erasing history here. So each time I'm starting from the same original state. So although it looks like the same, if I navigate to play, we do the same, navigate, route, play. Our behavior is different. Its behavior is not the same. And we will notice that it's not the same if we use this button. Because this just goes to previous state. Okay? But if I do navigate to play, it will be additional state on navigation stack. It will add extra entry into history of navigation. Is this clear? Last time I forgot about this part to tell you this part. This is why we repeated this. A difference between pop and just navigates to previous page. Because pop, it will actually go to previous state with history and remove current state. This popping the stack. Questions? Let's see. So what happens in some things are not explained, so I really have to mention that. Where these images are coming from? These images are just copy-pasted from, how did they import them? First I had to find them, right? So I found the images on web, and there is a piece called Resource Manager, so let's find it. Pull request, oh, here it is, Resource Manager. Okay, I click it, drawable, I click it plus, import drawable, yes, this one. Import drawable. I found this on hard drive, highlighted and added this. This is how I added these images. This is not end of the story. This is how I added them. One more thing that is not explained yet. In the project, there is icon for this one. Some icons come with library, so you can refer to them icon.name. Right? So for example, this arrow came with library. So this arrow on the button, let me show where it is. Or this angle, it is the same. Not angle, check mark, this one. So let's go to play screen. These icons outline a check. Back. This is how this part came from. But not all icons are available this way. For example, this question mark in the circle is not in this library. So we had to use some other trick in order to get it. So how did I do it? I click on drawable, right click, and I set new vector set. After this, I click it here, and there are choices, and we can search. So I type it help, I found this one, click it OK, I got it here, I click it next. It's showing me in red because I already have file with such name here. And when I click finish, I got it in drawables. So my drawables contains this. Nope, not this one. Oh yeah, it is this one. And this piece, it is what I imported from library. So this is how to get more icons that that you cannot refer from icon dot. It will come as XML from Android library. So this is where this piece came from. Where did I get colors? Because you see, I have green color. I got some color that's under. This is gray color, but when you click on it, it is different color, right? So some colors are default, some added. So when you deal with colors, we need to find some reasonable color somewhere, right? And it's not all, we cannot just type number and hope it looks good. So, there is a site, there is a website called Material Design. Material.io. When you type material.io, it will redirect you to Material Design 3. I asked you to do lab with material design, and they discussed this page. Material Design 3 can generate colors, can do dynamic colors based on background image of the device. But if you want colors from the palette that you choose, click on Material Design 2. In Material Design 2, look for the keyword colors somewhere. Components design. Maybe it is in design, yeah. A design color system. Scroll to the bottom. You can read it if you want later, but closer to the bottom, you have a choices of colors that look reasonably good. This is where I got this color. Okay, so what you want is this number, right? After this, you go to resources. Not generated resources, these resources. Go to values, click colors, and you can create additional colors yourself, add it here. After you do so, you can get this color from a resource. It's one of the choices. This is what I did. Okay. Get color from the resource. How did I do it? Let's find it out. Play screen. String resource. R color green, and this is a name of the color in the source. Okay. R color green and color resource. This one. You can also use this number different way. You can add a color to color file. In UI theme, there is a color file. You can define variable, assign color, and that number. And after this, you can refer to this variable as a color. So it's another choice. Okay. So you have two options when you have a number for color, either to add to resource or to color file, and depending on how you added this, you can use the color. All right, questions? Also, there is this is about colors. There is also a trick. Please notice that it is changing what is selected, not when I click on radio button, but when I click anywhere here. See? It's also selecting radio button. So in order to do this, we have to use on click on this panel. And after this, I change state based on the click of the panel. You already know how to deal with radio buttons, but this is extra trick. So let's open that. It is play screen. And this piece, I defined this piece as a separate compose function. So let's find where it is. Call it select option. And this is on click. When we use radio buttons on click, we assign some lambda functions that will change state. But in this case, on click is null because change of the state happens when I click on the panel. So where it is? Panel, a card, when I click on the card, this card. And you see on click is passed from outside. So I use on click handler of cards, and cards has also on click function. So this is the difference from using radio button directly and clicking on the card. Questions? Also on this click, I'm changing frame color. It is just brute force. Or frame this border color around image. And also when it is clicked, you see its elevation is different, right? So elevation depends on if it is selected or not. If it is selected, it is 16 dB, otherwise it is 4 dB. So this looks, it's a little bit pop it up when it is selected. And depending if it is selected or not, color of the border, so this is border. If it is selected, it is primary color. If it is not selected, it is gray color. So border of the color of the image, color of the border of the image also change. After this, it is just browsing code brute force. There is no other tricks. Okay. Going through every line, it's probably just tedious. Questions? So go through the code if it is curious. Otherwise, it's just make sure that you understand how it works. You don't have to remember, obviously. Good.